Congruent, which you may have seen in some of the descriptions up until now, it means that they are exactly the same in both size and their angles. Okay, so these two, whilst they've been spun round, they're exactly the same. Okay, similar figures, however, are enlargements of one another. Okay, so the angles will all be the same as each other, but the size lengths, so the lengths of the sides will not be the same. Okay, but everything will be in proportion to each other. So the most common shape we see when considering congruent similar figures is a triangle. You may be asked to find missing angles or lengths, given that the triangle is either congruent or similar. So initially you're going to need to identify if the triangle is congruent or similar. For similar triangles, the corresponding side lengths when divided by each other will give the same ratio. Now, I've just said that quite quickly. So here I've shown that this angle here is the same as this angle because I've done it in the same color, and A is the same as P, which means that B would be the same as each other because we know that angles in a triangle add up to 180, and therefore that angle must be equal to this one. Okay, when I say that the side lengths divided by each other, so if I were to talk about this length here, I would describe this length here as PR. So PR, if I were to divide that by its corresponding length, so which one is corresponding to this one? So which length would be the same length on this?
AC.
AC, yeah, you're happy with that? So if I were to do PR divided by AC, it would give me the same answer as if I had done this length, so RQ, divided by which length? BC or CB. And that would also be the same as if I had done this length. So what would this length here be?
PQ.
And AB. Would it be PQ over AB? All happy with that? So what this length divided by this length would be the same value as this length divided by this length if they're similar shapes. Okay. So as I said, the angles will also be the same. In some cases, it's not always clear that they are similar. So we may have this shape here, and they've asked you to find some missing length. Well, if these lengths here are parallel, what does it mean about this angle here and this angle here?
They're equal.
They're the same. What kind of angles are they? Do you remember how we described them? Leonie? Corresponding. These would be corresponding angles. So you may want to add that to your notes. They're corresponding angles. I'll try and write it here. I'm just going to write Okay, they're corresponding angles. In a similar way, this angle here and this angle here would also be corresponding. Now you may say, well, hang on a minute, I've got a triangle here and a trapezium. How are they two similar triangles? Well, what we would do is we would consider this triangle here, this baby green one, as one of our triangles, and then we would consider the purple one as our second triangle. Can you all see that?
Yes.
So the baby green one and the big purple one. And we would, because this angle here is obviously the same for both, then we know that they must be similar triangles. And so these are common type questions that you get asked when it comes to similar triangles. So whilst you look at it and go, well, there's a triangle and trapezium, secretly there are actually two triangles in there. In a similar way, we've got this shape here. People often make a mistake when they're doing these ones because whilst they think, oh yeah, they're similar, they forget which angles are the same as each other. So if I were to have this angle here, which angle on the bottom triangle would be the equivalent to this one?
Bottom right.
Bottom right?
Bottom right.
Bottom left. Okay, do you all see that? How do we describe those angles? How do we describe?
Corresponding.
None are adjacent. But it begins with A though.
Allocated.
They alternate. Okay, so these red angles are alternate. Now, I don't know how you want to remember it, but see, if these lines are parallel, you see it kind of makes a Z. So I think A to Z, like the alphabet is A to Z. So alternate, but that's just me. I'm a bit special that way. So they are alternate angles. So these ones here would be equal because they're alternate. In a similar way, this angle here would be the same as this angle here. And these angles would also be the same. Why would these green ones be the same? How do we describe them? Almost, they're actually vertically opposite, and they're not always drawn vertically, but they are described as vertically opposite, and they are equal to each other. So, as I've said here, in these cases, for these two, it's often much better to redraw the shapes next to each other. So what I would do is I would redraw my two triangles, and I would fill in my information. Here I would redraw my triangles next to each other and make sure that I've got the corresponding angles in the same orientation. And when we do some examples, I'll show you what I mean by that.
How come the top left and the bottom right?
These two, they are the same. These two are in green.
And so are the others. Those are blue and
These are
red.
blue, sweetheart. You probably can't see them as well because of the shades not being down. Sorry.
Wait, what is the green thing?
Hang on.
Vertical.
Vertically opposite.
Hourglass.
This one, yeah? No, this one.
Yeah, is that like the two triangles that flipped? Is that what it is?
Well, so it's a kind of a rotation of them. So what I would do is I would draw this one here, and I would have my red angle here, and I'd have my blue angle here, and my green angle here. And then I would make sure that this one was drawn the same way. So I'd have to turn everything upside down and make sure. And it becomes a lot easier. Oops, wrong way. It becomes a lot easier when you've got numbers and things on them and letters. And as I say, I'll show you when we do the examples. Okay.